Good evening and welcome everyone. Before we begin, I'd just like to remind you that we have nomination forms for people who would like to join council. So at the AGM in a few weeks, if you'd like to join council, get a nomination form at the front desk. Also, during tonight's lecture, there will be some sensitive slides in the later half, sensitive in terms of we wouldn't want these photographed, so please don't take any photographs in the later half of the lecture. If you have any telephones on, please turn them off to silent or anything else to avoid disturbing everything during the course of the lecture. Tonight's speaker is Professor Lorna Dawson. She is a Commander of the British Empire, awarded in 2018 for her services to soil and forensic sciences. She is a Fellow of the Royal Society of Arts, a Fellow of the Royal Society of Edinburgh, a Chartered Scientist, a Fellow of the Royal Society of Biology. She graduated from Edinburgh University in Geography with a BSc Honours and a PhD in Soil Science from Aberdeen University. She is currently the Principal Scientist and Head of the Centre for Forensic Soil Science at the James Hutton Institute in Aberdeen. She's also a Visiting Professor at the Robert Gordon University in Aberdeen and a Professor at the Polytechnic and University Higher Education Cooperative in Portugal. She's a registered advisor with the National Crime Agency, a trained expert witness, and has worked on hundreds of cases with police agencies and lawyers across the UK and overseas. Professor Dawson has also been an expert witness in many high-profile criminal justice cases, including the trial of the World End murders. In her presentation today, there will be some sensitive slides towards the end, so please do not take any photos of those. But now I'd like to hand you over, please, to Professor Lorna Dawson.
Thank you very much, and thank you to the Society for the kind invitation to come and speak to you tonight. And thank you for all coming out on such a horrible night with the wind and the rain and the floods, apparently in the south side of Glasgow. So thank you, all of you, for braving those. I hope you can hear it okay despite the technical issues. But anyone, raise the hand. At the back, can you hear it okay? Brilliant, thank you. I can't seem to get the mouse is working, so I'll use that. Okay, so I'm based at the James Hutton Institute in Aberdeen, but I'm very seldom there because I have to travel around and travel to places where there's horrible things happen. But what I'm going to talk to you today is about that use of the ecological sciences, environmental sciences, within the criminal justice system. I'm going to talk about the context, I'm going to talk about its use in intelligence and how we can help in search, and also used as trace evidence. And also I'll finish at the end about the importance and the vital importance, as in many professions, of good communication, and good communication across the United Kingdom and across the world, because this is quite a niche discipline. So indeed often we have to go and travel to other countries where there is no expertise in this niche area. But we weren't the first to do it. It was actually done by the Romans. They used to look at the hooves of their enemies' horses and scrape it out and look at it. And by looking at the texture, the colour, they could work out from which area their enemies were coming from. And then the Prussian Railway was the first time that the principle of substitution was used. That's where silver coins were being stolen from the railroad. The barrel, the contents were removed, taken away, and replaced with sand. So what Christian Ehrberg did was he went to all the stations along the road and identified where the sand had come from. And doing that, the police were able to go and apprehend the suspects. But it was Hans Gross. He was a criminal psychiatrist. Now, in that time, many people studied philosophy or medicine, and then converted and also substituted their learning with other disciplines. And he talked about soil actually back then. He said that dirt on shoes can often tell us more about where the wearer of those shoes had last been than toilsome inquiries. Well, I don't think it's more. I think it complements and it assists the investigative process. But it was Gale Pop. Around 1904 was the first time it was actually used in a case investigation. And in 1904, he looked at the dust on a handkerchief. And from the composition of that dust, he could work out where a crime had been committed. And then in 1908, he looked at the footwear of a suspect. And I'll just show you now a little video of that. I'll stop it short, but it is available. It's from BBC 4 and it is available on YouTube. But I'll show you the very beginning here to where they examined the footwear. And this is very powerful because he took extreme care in sampling the items that he was examining. Now, in between this and current day practice, so in about sort of the 80 years in between, what they used to do is sweep everything together, hoover it up into a single sample. But the secret is taking the individual material with similar color and texture, and that way he was able to work out where someone had been and in the order that they'd been in contact with those locations. But one of the great, fantastic authors is Sir Arthur Conan Doyle. Now, he used both botany and soil science, and I've got a couple of slides on this. He studied to be a doctor, but he was interested in practical botany. In fact, he had a fantastic fascination for the poisonous nature of some plants. And he included that in some of his books. And indeed, he wrote little notes in his medical books. For example, he said the cerebrum is first affected, contracted pupils are detected. On tetanus, one mustn't bet. Secretions gone except the sweat. Lungs and sexuals, don't forget. AD. He was talking about the effect of drugs on the human body, such as opium. The cerebrum is first affected, the pupils are detected. You can see what a wonderful writer he was. And he used that principle of poisoning of different plants in the case, The Man with the Twitching Lip. Has anyone read any of these books? Fantastic, aren't they? But he also, thankfully, used soil and geology. And in the books, The Adventure of the Five Orange Pips, Study in Scarlet, The Sign of the Four, and The Hound of the Baskervilles, as well as mentioning it in some other books. But interestingly, around the turn of that century, 1906, 1912, he was asked to be an expert witness in 2 trials. And in both cases, he was presenting evidence on behalf of the defense. And in both cases, they were acquitted. Clever man. But in the study of scarlet, Watson said about Holmes, his knowledge. Geology is practical but limited, but he can tell at a glance different soils from each other. After walks has shown me splashes on his trousers and told me by their colour and consistence in what part of London he had received them. And that is actually true, because we put that to the test. I was invited by Dame Sue Black to be part of the Royal Institution Christmas lectures, and she invited me to do a soil part of the whole scenario of that crime that was being covered. And so we got 8 schools within the M25 to send in their soil samples anywhere. I didn't know where they came from. Send them to the labs, and we were tasked with matching the soil to the school. We did that. We looked at the elemental composition of these soils. We looked at the texture and the colour. And as you can see, this slice through there is lead, the concentration of lead across the whole of London. So we could build up the layers and work out which school, which soil came from. And I'm delighted to say that we got them all right. So that same principle of Arthur Conan Doyle started, that you can work out where it's from. Wigmore Street was where he managed to work out someone had posted a telegram just by the colour of it. And that is a distinctive colour of that particular place. So yes, it does work. But it was Edmund Locard in 1910 who really established the principles of forensic science. So forensic soil science or forensic botany are just those scientific disciplines, but with the F on top. They're pertaining to the law. And this was the forensic science that Edmund Locard first established. So it was whenever two objects come into contact, there is always a transfer of material. The methods of detection may not be sensitive enough to demonstrate this, or the decay rate may be so rapid that all evidence of transfer has vanished after a given time. Nonetheless, the transfer has taken place. So that's transfer, but it's also got to have persistence so that it can be detected, analysed, and tested for a comparison of a link from one place to another. You will all leave behind traces tonight that if we had to, we could work out who was sitting on which seat. Scary, isn't it? It's good. Every contact leaves a trace, so soil is not dirt, but soil is part of fragments of pollen, glass particles, anything that anyone takes into a crime scene or takes out of a crime scene that can be picked up, analysed, and used in working out what happened. But back to what is soil. James Hutton, in the time of the Enlightenment, was a geologist, and he looked at the deep meaning of time, geology. He was also an agriculturalist, and he defined soil as the living bridge between rock and life. And he said that we are to examine the construction of the present earth in order to understand the natural operations of time past. And I think we do that now with forensic science, because it tells us in a little time capsule of soil what is in it, where it came from, and how did it get there. But not all soils are equal. Some are more readily transferred than others. Some have more clay in it, some are wetter, hold the moisture, some are more organic, which are all characteristics of being able to transfer. But that variability that we get in soil allows us to discriminate between soils, and it allows us to have the confidence that not all soils are the same. So just because we get the same characteristics doesn't necessarily mean that the soil on the shoe has come from that place, because one's always got to consider the alternative proposition. Where else could that soil have come from? So if we've got very complex characteristics, it gives us a greater confidence, and we can compare it with databases of values, because it's not categoric, it is a probabilistic science. So we assign probabilities. But it has a high probability of transferring and sticking. It's often not seen or detected by the person who's carried out the crime. We can collect it, separate, concentrate, and now we can work with amounts smaller than that you will find under your fingernails. Of course, not you, because you wash your hands, but in general, that size of material. And we've got excellent computerized database facilities. Two of my lovely darlings, getting very muddy, but it just shows the principle that it transfers. And we have to travel by car or by foot. And this was one of the things that happened in COVID. We saw people wearing masks, covering up, gloved up, covered up, disposing of their material that they'd gone when they'd carried out a crime, covering up so they're not seen on CCTV cameras. But people are fond of their shoes. People can't wash their cars properly. People can't get rid of it unless they get rid of everything they've worn. But people like to keep their shoes, but shh, we don't pass that on to the wider public. We're all trusted in here, aren't we? And the soil evidence, simple splashes can be recovered from clothing, fingernails, and the bottom one, this was a burglary where the person that committed it, he'd been wearing his favourite jeans. So he'd got back home, stashed the goodies, chucked his jeans into the washing machine. Police arrived at the door and said, "Can we want to see your clothes. We believe you were seen on CCTV." No, it wasn't me. They took the filter of the washing machine and took the material out of it. We took material from the scene and we extracted it in the same way, the material through the washing machine, and compared only the minerals. We couldn't look at the organic part, but the minerals were virtually identical. And when they presented that, he admitted the burglary. But the botanical information, there's a whole range of different ways, from palynology, limnology, ecology, bryology, anatomy of the plant. There's the root system. We've used roots and the woody roots and the number of rings in a root system to tell the number of years that a body might have been there. There's a whole range of different methods. Also, diatoms, for example, can tell us whether the water that someone's been in contact with is more saline or fresh water because of that community that lives in the water. And of course, we don't do this, but there are experts that look at the stomach contents to work out what plants and time after death, and also if poisons are in the stomach contents. But that's also a branch of forensic botany. And as I said, we have to use cars or bikes or footwear to get from A to B. And we can analyze the material that's come from the cars. And in similar to the idea of taking individual subsamples, if we get a footwear mat, in the old days it used to be hoovered up and there'd be a single sample. Well, that's just going to mix it. If it's anything like my car, it reflects about 20 different places I've been for a walk. So no way could it be used to link to a specific location. So we get the whole footwell mat and the pedals all submitted as one unit. And we examine it and recover it under laboratory conditions with good light and the expert eye. But footwear is the main type of question sample. When I say question sample, that is a sample that we don't know where it's come from. We have no idea. It can be submitted to us, there's soil on it, it's got no link to origin. So we're asked, could you see if that could have come from place A, B, or C? Or even worse, can you give any indication of where it might have come from? So we have to use that, and we use the stratigraphy. We use the fact that there might be 6 or 7 different sources on one item of footwear. And the middle one there was from a rape in Edinburgh. And as you can see, there is the soil on the front, the position that it is on the shoe is important. And this was where the activity took place. And what we also got was from the SPA forensic scientists took impressions in the ground, and that was comparable with the type of material that the plastic upper was on that boot. And we've got vegetation, the bottom image there, we've got grass, beech, and birch leaves. And again, that was comparable with the habitat of where that rape took place. And again, the person who committed that crime, when they were shown this, admitted to the crime. But soil implants can also tell us things like, what was the access route? What was the exit route of the perpetrator? How long had that body been there? And also here we've got a plant, the plant growth conditions, the rate of growth can tell us how long a body had been there. So it helps the police work out who's gone missing at that time window. Because sometimes, once the body's skeletonized, it's very difficult beyond 6 months to get an accurate time window of who it might be. Multiple questions in forensic science, from who was involved, and this tends to be the pathologists, the forensic biologists, what happened. That's everyone. How did it happen? When did it happen? That's very difficult. Even, the pathologist's time of death is increasingly difficult. Although we're getting more indicators, there are insects, there's entomology that can be used. And ultimately, we all ask, why did it happen? But what the ecological sciences bring to bear is help to answer predominantly, where did it happen question. And it's all as part of a teamwork. from the question from the SIO, oh, can you help us work out this particular location, right through to the ongoing science, which I'm sure some of you are involved in, that may one day develop to being application within forensic science, the criminal justice system. And ultimately, once it's peer-reviewed, once it's published, once it's been tested in court, then it can be applied within a discipline, within a court setting. And there's multiple ologies that all work together. Different experts, depending on what specific case question. If there's a surface burial, an archaeologist does not have to attend. If it's a burial in the ground, then it's preferable that a forensic archaeologist and a forensic anthropologist attends. A soil scientist, if it involves also a burial situation or transfer of soil. But all these experts can bring something different to a case investigation. Once we get an item submitted, that question sample, and here we've got a pair of trousers, again, it's not just one sample, but several samples that would be taken that would reflect the different materials on that item. A footwear, here we've got a red-brown soil with conifer needles in it. That has come from a different location to here. And then here there's a third type in the middle. Now that would be probably 4 different samples that would be taken to reflect the different places that's been. But it's not just the soil. The hours that we spend looking at the item under the microscope, because sometimes you can find really distinctive things, such as here's a little bit of plastic. That plastic was on a suspect's shoes. There was also the same fragments of that plastic in the ditch where he deposited the young girl's body. A human hair, that gets put into a vial and sent to the biologist. A dog hair, Lucy, could send that to you to identify what breed of dog and even down to the individual one. In that case, it was a pet, a house pet, and the person who'd been in the house, this hair transferred to his shoes, and it was able to be matched with that of the house pet. There was no other reason he should have that hair on his shoes. Diatoms, little bits of metal, hair, bits of skin, you name it, we've seen it. And actually, you might think that it's more difficult in an urban situation than a rural situation. Well, it's actually, we are getting more distinctive things in cities. Things that reflect fly ash from industrial, distance from a road we can get by the metals that we find in soil. So it can be very distinctive urban situation. And that approach of taking individual samples, here we've got a lighter brown and a yellow brown, we would split that sample because that way we're going to get the best comparison between that question sample and the location it might have come from. Soils are complex. Complex because they've got mineral material that reflect the geology, the parent material. Organic, which reflects the decomposing plant material and animal material that end up, break down, but leave signatures behind. And then the living part of the soil, that DNA. I love to say it, that there's more organisms in a teaspoonful of soil than there are people living on this planet. That's the power of soil. And all of that together with the air and water, that makes up the wonderful thing that we call soil. And we've got a whole range of different methods. It's not just one method we can use, but a whole multitude of methods, depending on the size and the condition of that soil sample. And here's just some, I'll not go into the details, but depending on how it is and the size of it will affect which method we use. And also one of the wonderful things we've got in Scotland particularly is our database, our soil and land cover data. I would ask you to go along and look at Scottish Environment Web, SE Web. You can put a grid reference and you can find out what type of soil, what's your water quality, what's your air quality at your specific location. It's wonderful, it's free data, it was paid for by the Scottish Government, so it's freely available, and we use it within our database when we've got a question sample and we're asked, well, where in Scotland could it have come from? We've got over 40,000 soil samples in that archive, collected from the 1930s to now, and we've got systematic surveys. And these systematic surveys give us information about the soil profiles, about all the characteristics such as NPK, elemental composition, isotopic composition, organics. It was resampled in 2009, and we now have multiple subsamples in the -80 freezer. So we're able to look at what characteristics of the biology tell us about where it came from. We've got full national coverage at 1 to 250,000. And around all cities, we've got 1 to 25,000. And you can take any one characteristic, such as soil texture, and you can draw out that map and see where you find all your sandy soils or your clay soils. You can find that out at the click of a switch. And that information also coupled with land cover, land capability for agriculture, forestry, by using that information together, we can narrow down where something's come from. So for example, we've got organic characterization by gas chromatography, or FTR or X-ray diffraction to quantify the minerals. Or if it's such a small amount, we can use scanning electron microscopy and EDS to give us the elemental composition. And all of that can be compared with the database and that spatial data to help work out the where question. And that's the data on the right-hand side, the information about the geology, the soil, the land cover, coupled with the police information. It's bringing it together in a digital way. The last known position, CCTV, where they use the credit card, what's the maximum likely distance they could have travelled. All of that is brought together in the GIS map. And we were asked to do that for that Catching History's criminal programme. And to do it, we analysed the soil. And we could see it was not an urban soil. It had none of the pollutants. We knew it wasn't a peat. It had none of the fibrous particles we'd find in peat. There was none of the chemical non-ecosinol, which is always in coniferous soils. We could exclude them. It was not an arable soil. We just had the whole of Scotland. And then we would add in the characteristics, the colour of it, what pH it was, the carbon content. So that was taking us to an area of deciduous woodland north of Glasgow here. And then we put the layer of accessibility. Remember, people have to go to somewhere. So to get somewhere, they probably got to drive a car. And if somebody's getting rid of a body, a dead body is a very heavy thing. And they will be lazy. And 99% of bodies are carried downslope, and they're carried 50 metres from where the car has parked. So we can use that information to help work out where the best place to search is. So in this case, we narrowed it down to 3. Gabby Weston came along and she announced where she'd been. And we said it was this area here, Muddock Country Park. And she said that was 700 metres from where she'd walked. So if anybody's interested, that's available on part of that programme. But I'll show you this one because this is only a 5-minute clip. So not to be outdone by BBC 4, the one show on BBC 1 said, can you do the same for us? Could we send a presenter somewhere in the whole of Scotland and we'll announce it live on television? I thought, no, I'm going to be really put to the test here. So let's see if we get it right the second time.
Well, we interview a lot of experts on this show, but I don't think any of them have been put on the spot quite so much by our presenters as much as Professor Lorna Dawson.
Yes, she put her reputation as one of our finest forensic scientists on the line for Marty, so let's see if she'll regret it.
When it comes to crime scene investigations, cases can often hinge on tiny microscopic details, like hairs, saliva or blood. But what if the only evidence of a crime is mud? Surprisingly, evidence from mud has been used to link dozens of murderers to the scenes of their crimes. So how precise can it be? I've been for a walk somewhere in Scotland's 30,000 square miles, and I'm setting forensic scientists a challenge. Can they put me in a specific place using only the mud on my boots? The exact location is hidden in this envelope. I'm taking my sealed envelope and muddy boot to the James Hutton Institute in Aberdeen, and to Professor Lorna Dawson and her team, the UK's top forensic soil scientists.
The clues that are held within that soil, those can tell us where that person has stood. So we're looking at fragments of vegetation, we're looking for hairs and fibres to compare it with soil at a crime scene.
So how close can Lorna get to pinpointing where I've been walking? First, a simple visual inspection can reveal quite a lot.
It tells us, because there's a very, very small proportion of sand in this sample, that it's not come from a beach environment, it's not come from a riverbed type environment, it's not got fibrous peat in it, so we know that you've not likely walked on a peatland.
Looking at the soil, Lorna's expert eye immediately rules out parts of Scotland I definitely haven't been. The next step is to identify the underlying geology of the area I was walking in. And for that, Professor Steve Hillier uses X-ray crystallography.
Soils can have a very strong relationship to the rock type underneath them, so-called parent material.
Scotland sits on dozens of slightly different rock types, clearly marked on geological maps. By using X-ray crystallography to calculate the exact mineral makeup of my mud, Steve can work out what kind of rock lies underneath.
This blue one here is a zeolite, and we've also got a mineral called a pyroxene. So my initial thought straight away is this must come from some kind of igneous rock.
Knowing that my mud sat on top of igneous or volcanic rock means Steve can start to narrow down likely locations.
It matches very closely with the kind of igneous rocks that you find around Edinburgh, Stirling.
But also hidden in the soil is biological evidence, far too small to be seen by the naked eye. Holland specialist Ilse Kamerling is using a powerful microscope to look at the soil in minute detail.
Some cereal pollen, which suggests a meadow or a field probably surrounded by an area where cereals will be cultivated.
Okay, what else?
Spores that are produced by fungi that grow on the dung of animals.
Finally, Lorna cross-references the composition of my sample to a huge database of 30,000 soils from across Scotland. She's now ready to reveal her results, starting by eliminating where she thinks I haven't been. Lorna, tell me about your results.
So the dark coloured areas on the map, are those that are sandy. Okay. So you did not go there.
I wasn't there, okay.
You didn't go to peatland areas. You were not on an arable farm.
Right.
We're excluding all the areas in Scotland where there's conifers growing. Then we looked at the carbon content of the soil. We add all those different layers in, and it
doesn't leave much, does it?
No.
Having ruled out most of Scotland, we're down to a scattered collection of possible locations. Next, she looks at which of these remaining areas match the rock profile from Steve's X-ray crystallography.
So one of the main characteristics of the where question, where you were, is the soil, the geology, the underlying bedrock. But one of the areas that we thought most closely compared was at Dalmeny Estate.
Okay, that's your final answer. Well, in here is the actual answer.
Okay.
I'm looking quite nervous. So, here it is, and the answer is the Dalmeny Estate.
That's fantastic.
Queensferry, you were absolutely bang on. I could have been anywhere in Scotland, and yet Lorna pinpointed my location to...
So we got it right. But what they didn't say was that I actually we applied all the methods that we had available to us. There was a huge amount on the boots, so we could get that narrowing down of location. But I went to 3 different locations, one in Stirling, one in Edinburgh, and one at Dalmeny. And I ground truthed it by getting reference samples from these areas, visiting them, and working out just the subtleties of which were more similar. And it was the one at Dalmeny. And also I did think about distances, because BBC must be on a budget, so they would have to fly it. So this one was probably nearer the airport. So no, we didn't, but it is a consideration. But soil is variable, and we have to consider that transfer and persistence, because that soil on the footwear will have gone through a subtle fractionation process compared to the reference sample. So we have to take that all into account when we're interpreting our data. And the two main areas, so the question by the investigating officer is, do you know where that soil could have come from? And that's exactly the same principle that I showed you there from the one show. And then the other question is, did that soil come from that crime scene? And that's a source level question. Now, it's important that for that, and if we're asked, did that suspect, Y, dig that grave? Then we need other information to take it from source to activity level. We need the DNA on the handle. We need who used that spade. What's the population of spades in that area? All of that. But one thing, the expert never comments on the offence level. That is for the courts to decide, not for any expert, not for any lawyers, not even for the judge. It's for the jury in our system to decide, was there evidence at the offence level that the person was guilty or acquitted. Those two areas here. And in the area of the intelligence investigative, where we're excluding the area, it's so important we've got these databases to rely on, accurate databases. And for evidential, we need to know about the uncertainty. We need to know about the variability that you get. Because it's like betting. It's odds. It's likelihood of it coming from this crime scene relative to the proposition of the defence, who says that they got it from their home garden. But sadly, it's no comment. So that doesn't give you soils to test. So if it doesn't give you another location to sample and analyse, then that's where the population of our database comes in, because you can consider other soils of that type and habitat. Could it have come from that? So it gives you that likelihood ratio that can help either the prosecution or the defence. The expert's duty is to the court. It's not to whoever commissions them to do the work, and that's very important. So now I'm going to go into the second half of my talk, where I'm going to talk about actual cases. So I'm really grateful. These are slides that address these cases, and some of them are sensitive. So I'm grateful that no one takes any images. Thank you very much. Do many remember in 2015 when a beautiful Irish student was in this city of Glasgow visiting? And sadly, she went missing. She was at the wrong place at the wrong time. You're more likely to be murdered by somebody that you know. I think it's something like 80% of murders are committed by someone that you already know. This was one of the 10% where she didn't know him before. She went to the Sanctuary nightclub not far from here, and this gentleman here, Angus Pacto, was at the same nightclub. She went missing. Her friends noticed that she wasn't there, and they thought she'd maybe gone home. She hadn't contacted anyone, and CCTV cameras showed that this was the man that she'd last spoken to. And she was seen going off and getting a lift in his car. He was also seen on CCTV in a DIY store buying a barrel and caustic soda. At the beginning, there was a hope that she might still be alive. Usually, all the biology is done first on any of the questioned items, so the DNA, blood, fibers are recovered. But in this case, we were sent one of the shoes. If you look at that shoe, I don't know if you see it at the distance you're at, but that certainly is not a shoe that you would wear to go out for a night out. It's covered in mud. That is unusual. So we took that soil, we analysed it, and the coloured map behind it is the Scottish soil map. So I entered the characteristics of the soil. We did a fast turnaround in the hope that if he'd put her somewhere and he'd been somewhere, she might still be alive. We found that it matched the area that is blue here, and that is High Craigton Farm. And the police found out that he had a lock-up unit there. Very quickly, it was multiple scenes. I attended at the deposition site here at the High Craigton farm, and sadly, her body was found in a barrel in this lockup where he had been to previously. So we sampled around there. We sampled at an area that was a burn site. Again, CCTV saw his car going out of Glasgow, north of Glasgow, with a mattress in the back of the car. There was a partially burned mattress at this site. So we took samples of that. That was the burn site. Sampling the vegetation and sampling the soil, sampling any access routes at all locations. And the other site was Dawson Park, where our handbag was found. So again, rigorous reference sampling for possible points of contact. And here was an area where there's a bin. You possibly go there to walk yourselves. Lovely park. We took samples there, and his vehicle was seized. Now, he'd taken his car to get thoroughly washed. Apparently, this may not be true, but I was told by one of the investigating officers that in Glasgow, you can take your car to get a crime special. Is that right? Anyway, he'd taken it to get a crime special, but it hadn't been done well enough, thankfully. And what we were able to do was recover the soil on the underside of the tyres. And you can see there's a significant amount of material there. So he's run through quite muddy area. So we were able to compare that. And we used gas chromatography mass spectrometry for that. And the pink line is it's the shape of the hump that we're looking at and the rider peaks. And it virtually overlays the sample that was at that bin at Dawson Park. So that car had been at that location. And we also look at the specific organic compounds in the footwear, the car, under the car, and compare it with the reference sampling. And I won't go into the details here, but we're looking at the pattern and we're looking at the concentrations. And basically, the right boot had the same shape and pattern as the burn site. He'd been at the burn site, he must have come out there. The rear tyre was the same opposite the park, Dawson Park, and the driver's pedal was the same as that at the access road. So basically, all of the scientific rigour, the interpretation, evaluation, but the soil that was on the pedals had similar characteristics to that outside the shed where she was found. The soil in his footwear was the same as that at the High Craigton Park, the same as at the High Craigton farm, and the underside of the car was similar to that burn site, and the tyres of the car was very similar to that at Dawson Park turning point. Puts the story together along with the fact that the police, what a fantastic police operation, what dignity and integrity the work they did, and they found the spanner with his and her DNA on it. They recovered it. There was so much evidence that linked him to killing her that he pled guilty, and it saved her parents the devastation of going through and listening to what had happened to their lovely daughter. That is available. I'm not going to play it tonight, but it is available on
when a serious crime is committed
Witness
and the police need all the help they can get.
But there's not time tonight, but you can look it up on iPlayer if you're interested. The next case I'm going to go to, and it's not that all of the murders happen in Glasgow, please, that's not the case. But I've tried to pick examples that are close to here so that you are reasonably familiar with them. The next case I'm going to go to is that of the death of Emma Falls in 2013, south of Glasgow, Kilmarnock area. She went missing. Her family didn't know where she was. A very astute crime scene manager found a pair of muddy boots in a cupboard, thrown at the back of the cupboard, sent them up to us, and you can see here on the top, there's dark staining, very peaty, and what we could do is look at that both inside the uppers and also in the sole, and we were able to recover tiny pieces of soil and also vegetation, a lot of mosses and heather on the cracked sole. And they didn't look that dirty, but we were able to get a lot of information from that. So working with the botanist, so the forensic botanist in my team, he was able to identify 4 different mosses species I was able to look at the soil and say it was definitely a peat, it was a boggy area, and he also found Cluna vulgaris. So you're starting to think of what kind of habitat is that? So in the forensic strategy meeting, I was able to feed back to them, well, the area that you need to be going to search is one that is, there's peaty standing water, so it's wet, the water table's high, there's also this composite mix of these mosses, that type of habitat, but there's also heather, but there's also the occasional Sitka spruce needle there too. So it allowed them to move from this area here more west. He had worked as an engineer on the wind turbines, so the theory was that he'd understand where that environment was, but we suggested they move further over to the east in this red zone. So the next day they went out to this area. They let the dogs out when they drove up a lane just to refresh, because the search team have these dogs which are absolutely brilliant. The police dogs are so good at finding things. If they're trained on the right substrate, they will find it. They got out. Within 10 minutes, they found Emma's body in a ditch in the Sitka spruce forest. Here is a little patch that had been left. From the rest was clear feld with the next rotation going up, and that the green dot indicates where her body was found. But it was in the middle of nowhere. If we hadn't homed in the search on that particular area, she might never have been found. So the scene was cordoned off. We went to the scene and the pathologist came and recovered her. Very sad. But what we could look at was these exact same mosses were there. This was strong evidence that what he'd done in the same peat, he'd lifted the clumps of moss and put them on top of her body. And in doing so, he'd exposed the peat beneath these mosses. That had transferred to his boots, and we were able to analyse it. We took reference samples at possible route in and route out. So these are the areas that are sampled for contact with the boots. A common approach path is taken away around the back, so we're not going to disturb the area that we want to sample. And then reference samples further alternative locations where, say, material on a car might have gone. So we did all that analysis of inorganics and organics of the material and came to the conclusion that there was strong support for the proposition the material on the boots originated from the ground at around 9 and 10 markers, and that was where her feet and just beyond her feet were. And it was moderate to moderately strong support for the soil having come from the deposition site. And then we can also do the alternative proposition, any other organic soils that are on that type of vegetation. So we can look at that likelihood ratio. But there was also a few vehicles. So here is a sample. I'll just focus in on this one here on the rear, stuck to the area near the exhaust. We analysed that, and that one was strong support for that sample having come from the deposition site at marker 1, and marker 1 was at the end of the track. So again, that is logical that he'd reversed in and it had splashed up. There had been rain just before this time, so that was evidence. And in court, the jurors heard and found him guilty, and he was guilty of murdering Emma Faulds before dumping her body in that remote forest. Got a minimum of 20 years. Now, there was other evidence. He'd taken her car and left it at her flat, and he'd been seen on somebody's dash cam wiping down the handle and wiping down the steering wheel. So there was a lot. He denied it right to the point of court, but all this evidence was presented in court and helped the jury decide he was guilty. And again, there's another one on this case that on BBC Player. The next case is Emma Caldwell. Again, that's one of the girls from Glasgow, originally investigated in 2005, and then I was asked to come in and help in 2021 in the reinvestigation. She was found in these woods south of Glasgow. There was sampling done at the time, but nothing concrete had come out of that sampling. They'd done some pollen work, but it wasn't accurate. So we were asked, this was his vehicle. Thankfully, they'd taken samples at the time and they'd been retained securely in evidence bags. But it was Sam Pauling, the BBC investigative journalist. she interviewed him, and she was able to bring out the fact that he actually had attacked women before and that he had been with Emma. And he eventually admits, this is some of the data, I'll not go into it, but he admitted he'd been to the forest eventually. Originally he said, no, I've never been there, it wasn't me. Then, when there was some evidence to suggest that the soil, when we were analysing it, was similar in his vehicle to there, he said, yes, I have. Oh, I remember, I had been there. But look at this variation that we've got within that forest area. So he said that he had been there. So we said, well, where is it? The police asked him, and he identified the area that he'd been to. And we were able to look at it, sample it, take multiple samples. And you can see this is the soil that was in his vehicle. The two in the middle is the soil at a molehill very close to where Emma was found, and the two on the far right are those that was resampled. We had to check that that hadn't changed over that time. And then when he said where he'd been, these are all the samples of the area that he said he'd stood in. Well, you don't need to be a scientist to say that that's different to the 4 that came from the vehicle. So his alibi was gone, and indeed we were able to show that, in my opinion, the observation is more probable of the soil material from in the van originated from the murder locus, about 2 meters from where Emma was found in the ditch, having originated from rather than anywhere else. Indeed, it was so similar. And Ian Packer was found guilty of her murder, 36 years minimum. And the last one before we have a break, and I'm sure you're all wanting to get a glass of water or something, or burning some questions to ask, is that of Anthony Parsons went missing in 2017. Tony Parsons, the cyclist that was cycling for charity. You maybe remember the posters, the massive search operation, and he wasn't found. Not a sight, not a sound of him. Not a thing found. They searched up and down that road from the Bridge of Orchy to Tillycutry. Nothing. He was last seen on camera as well. I haven't got the picture here, but he was last seen, it's in the bottom one here on the right, the left, cycling at the camera coming out of the petrol station, and he was wearing a red top. You don't see it very clearly there. But that was the last physical sighting of him. Massive search, nothing found. So when I was brought in, it was during COVID, and what a nightmare of a logistical operation. But so I did the soil searching, this is remotely, and the vegetation. There was a witness had come forward and said that these boys had admitted to them that they had buried his body in a remote bit of the woodland and then moved him to an area in the uplands. And they knocked them down on the road going back. So I went to the area with the police, and we identified an area that was consistent with having been disturbed in the last few years. And here, for example, you see a broken bit of the branch. It's not yet broken off or decayed, so that's consistent with being disturbed. I took soil cores, and I was able to look at the soil cores and see that the area had been dug up. Normally you get a stratigraphy, so you get the fibrous peat at the top and the amorphous peat deeper down. Well, around this area it had been mixed up. So this was not a natural peat profile, it had been disturbed. There was ice on the surface, there was no surface vegetation. So we immediately set up there's a normal peat profile. You see the fibrous peat at the surface, and as you go further down, there's less structure, it's amorphous deeper down. Well, that amorphous material was near the surface, and that fibrous peat, plus some vegetation, was down at 50 centimetres. So we knew that this was an area that was worth excavating. Brought in diggers, until we did. On the second day, we found that red bit of fabric, and we'd found Tony Parsons. And at least he was going home to his family, but he had been buried there in that remote peat bog. So the scene tents went up. That's material we found at 20 centimetres. It had been dug in. Different vegetation. All the material was taken down. All the material that was around him was sieved through in this sieving tent with the water from the river, taking out all the materials. Now, what we were looking at was what was around his body that might indicate what had happened to him. We found little bits of wood chip. That's not naturally in this peat bog environment. What we found at the farm was the same size and shape of wood chips. We found bits of straw, stained straw, the same type of straw, the cereal straw was found at the farm, manufactured bits of wood at the farm, rhododendron leaves, right adjacent to his body, found at post-mortem. The same rhododendron species was found outside the farm where the boys lived. Birch, beech, exotic pine in the policies at the estate house, all of these were found in his body, around his body. They were not in the yellow area where he was found at that peat bog. None of that found in that area, but all of it found in the area adjacent to where they'd accessed where they lived. And that fitted with the story that they'd knocked him down, they'd left him, got another car, gone back and got him, left him overnight in this wooded area in a ditch, gone shooting, killing the deer. Then they'd gone back, scooped him up with the wood chips in the digger, in the bucket. I'll show you that in a minute. It met all those characteristics. On the farm, there was the digger, there was the bucket, and the forensic archaeologist was able to give an opinion that the shapes that we found in the grave where Mr. Parsons had been were the same shapes that were made by this bucket that was still at the farm. And they were only one of 4 people that had keys to this digger. And the same wood chips and the same cereal straw, all adding up to help the investigators work out what happened to poor Mr. Parsons. And in the deer larder, there were deer hanging there with the offal, with the lower part of their legs. A forensic veterinary surgeon came along and opined that the deer offal and the deer bones that were put on top of his body in that grave had likely come from the shoot that they'd gone on that day. So back to Lockhardt's exchange principle. Mr. Parsons was found in an upland bog. He was also found with the woodland vegetation, not found there, but at the farmyard materials and deer bones. All of those consistent with telling the story that he'd been left on his own in a ditch outside the farmhouse, away from anyone. And they were found, they actually pled guilty to culpable homicide, so it didn't go to trial. 12 years, and his brother got 5 years. So I will now finish with the last case, which is, and I'll show a small clip, and that's the case of Rennie McRae and her son Andrew.
He had an alibi for the evening of the disappearance. It distanced him from the lay-by where Rennie's car was found.
Mr. McDowell gave quite a detailed account of where he had been on that evening, from leaving his work to the journey home. His wife supported Mr. McDowell's alibi.
Detectives now wanted to interrogate Bill McDowell's alibi, and once again, they turned to advances in forensic science, enlisting soil specialist Lorna Dawson and her team at Aberdeen's James Hutton Institute.
The suspect had said that his vehicle had only been in and around the Inverness area, and certainly he hadn't said that he hadn't driven south of a place called Daviot. 2 or 3 miles south of there was Dalmagary lay-by, where Mrs. McRae and her son vehicle was burnt out.
In 1976, investigators collected soil samples from McDowell's car. They had never been analysed. Detectives now hoped these could reveal whether he had in fact driven to the area where the BMW was burnt out.
Each sample is examined under the microscope. It is extracted and prepared for a whole suite of analyses to tell us about the suite of elements that are present in that soil. The second phase was going out and sampling around the areas in and around Inverness where Mr. McDowell said he had been, and in and around the areas south of Daviot, and then being able to analyse those samples for potential contact with the vehicle.
To reveal just where this material could have come from, Lorna had to run her findings through a sophisticated and unique asset.
In Scotland, we've got one of the best open source databases that there is in the world. The Soil Survey of Scotland in the 1970s went out and sampled every point at 10-kilometre grid of the whole of Scotland for a range of characteristics, pH, elemental composition, mineralogy. We've got that data now totally digitised so that we can search it in a computer, so we can compare it digitally with what's held in the Scottish database.
Crucially, Lorna and her team would be in a position to confirm whether McDowell was telling the truth about his movements on the evening of the disappearance.
The vehicle samples were of a granitic parent material, and of the reference samples, the ones that were closest in that characteristics were two that were down south of Daviot, at and around Dalmagary, lay-by. They were not in any of the areas north of Daviot. This information refuted the proposition by the accused that he'd only been in and around Inverness that night.
30 years after the crime, McDowell had been caught telling another lie.
So in this particular case,
McDowell
was able to show that he hadn't been where he'd said he had with his car, because the soil on it had been from the area around Dalmagary, not in and around Inverness where he said he'd been. So all those years later, it's never too late. There's never a cold case that's not worth investigating. But it's important that we can communicate it, and we communicate it in the right way, not in a sensational way such as the CSI effect. It's not glamorous. You don't wear fancy clothes. That's me on the right. It's got to be done carefully, with caution and clarity and clear recording. But back to that, one of the best ways of communicating to the jurors, to everyone, any one of you could be the one making a decision whether somebody's innocent or guilty, you'll more likely get what evidence is by reading crime fiction than you will by reading anything I write. So I work with some of the crime writers. They're fantastic people, and they try to get it right. And for example, around Glasgow, we've got Lynn Anderson, Alex Gray. Alex Gray, for example, she included it in several of her books, the whole soil and ecology. The skeleton was probably not going to be found intact, he guessed. It was not the first cadaver Lorimer had seen buried deep in a makeshift grave, but he still felt a shiver down his spine as he gazed at the bones. Whoever this was, it had to be identified if possible. He shifted his position, hunkering down on the plank, and tried to examine the skull more carefully without touching anything. Was that a bit of dirt? And then Lynn Anderson, in her book, based in Glasgow, her father was a police officer in Glasgow, and she obviously has that investigative mind. And you want to know if the soil samples match her last known location, Jen said. Jen is my name in her book is Jen Mackey, Professor Jen Mackey. So said, which, as I understand it, was at the Rosneath Games. That's the last place the child was seen, Rona confirmed. Then again, if they come from elsewhere on the peninsula, Jen didn't say it might point to where the child was possibly buried or the actual location of her drowning. But Rona knew that's exactly what she meant. And then over a bit in the central bit, cover Edinburgh a bit. Val McDermott, for example, she says that place is important, and she builds geography into her crime novels. She said, the best crime novels are like a three-legged stool. They depend on character, story, and setting. Don't underestimate the power of setting. If you write about place in a way that for someone who knows the place, they're absolutely there with you, then they trust you with everything else you're telling them. And that's true. If you can picture yourself at that location, if you can trust the forensic science, if the crime authors have done the research, then it's going to do a really good service. And Ian Rankin, I like this one. He said, the MIT office had made room for visitors, including the soil specialist from the James Hutton Institute in Aberdeen. Professor Leanne Ingalls, I'm called in his books. She was in her early 40s. Thank you, Ian. With long brown hair parted and tucked behind one ear. She'd come armed with data. She explained to the room about soil fingerprints and the records she had compiled from hundreds of samples. A few crumbs on the sole of a shoe or embedded in a tire could pinpoint where that shoe or tire had recently been. And I think you've seen some examples tonight where that's been the case. So I asked Ian, I said, why do you do it? What's the importance of crime writers to do this, to do your research properly? He said, I began writing the novel knowing I would have a car. I'm not, spoilers here, so if you haven't read it, I'm not giving anything away. But also had been undiscovered for many years. I knew forensic investigators would check it thoroughly. Part of that would involve a check of the dirt found on the tires. The dirt gave clues that the car had been hidden somewhere far from the location where it was discovered. This gave me an extra puzzle for the reader and my detective to solve. Science and technology are crucial to the investigation of crime. Readers know this, so authors should take account of this. So, and also I've worked, and I won't show you them, but there's a few examples in the past of silent witness. Recently, it's gone a wee bit too far.
Why was Benny? Where was he coming?
I don't go with the fact that they send the pathologist out to question the suspect. It's gone a bit too far. Anyhow, ultimately, it's the court. So what we did with the Faculty of Advocates and the Open University was we all acted in our own roles. So we had a retired judge, we had a prosecutor, deputy advocate, PC, we had a defence lawyer, we had court clerks, and we ran an hour-long court case written by Douglas Skelton, and we had 3 different
Ladies and gentlemen, the charge against the accused Paul Anthony Darren
and this
is that on 19 November 2018
so they can
at 118 Dumbarton Square, Glasgow.
Court. So I'll not, but it's there. And there's also a series now called Murder Trial, and this is one episode of a case that I worked on, and it's a good one if anybody's interested. To really, if you've never been a juror, to go into a court to understand the whole workings of that system. You have to learn that language if you're working in that context. And we have to know our publications, we have to follow protocols, and we work with people, and it's teamwork. From my team in Aberdeen to the colleagues that I work with, to the investigators, to the media, to the police, to everyone, the lawyers, the Faculty of Advocates, the societies I'm part of, all of that contributes to me. I was made a little, this is a Geological Society, a little Royal Geographical Society. From the work on the peat to crime scene, to lab, to court. Thank you for listening. And I think I would, before we've questions, I'd like to play one little clip. Recovering Anthony Parsons from his makeshift grave, where he may have lain forever had the investigators not uncovered where he was. It was a very emotional moment when he was recovered by the Police Scotland Mountain Rescue Team. They came and they took him back. They took him away. And we stood with our heads bowed, and I think that we just take a minute to reflect. It's the victims we remember, not the perpetrators.
Reverend
That was the place where we were recovering, searching, and ultimately turning him home to his family. And that happened to be a colleague of mine who was walking on the bridge of Orchy Montrose and looking down on the area where we were working. Not intrusive, it was after we had recovered him, but it's just so poignant because it's such a beautiful place, and sometimes it's so sad that these awful things happen in these wonderful locations. But just be thankful that we're actually relatively safe in Scotland, and that we've only just over 100 murders every year, which is much less in a country our size. It's quite a small number. It's much worse in a lot of other countries. So we've got a great police, Scotland, to serve for us, and great forensic teams, and a great legal process. So thank you very much for listening to me, and I'd be happy to take questions. Thank you. I wanted to do that.
Just give a moment for people to leave. Okay, Pat, in the middle on the right, please. Oh, okay. And hold the microphone like that, please.
I wonder whether you were ever contested in court, and if so, by whom?
Yes, it has been tested several times. I've been in court, must be about 30 times now. The first time it was actually used in the Scottish courts was for the World's End trial, His Majesty's Advocate versus Angus Sinclair. Sorry, I can't remember the year, but that's where he got 37 years murder for murdering. And that was where soil was used. It was, again, it was in a cold case, and it was the first time of double jeopardy. That was the first time it was used in Scotland, the soil on the feet of Helen Scott. What we were able to show that she had walked in two different places. So the soil on her feet, which she'd kept in 1976, Lester Knibb, the forensic scientist, had recovered that soil, and it had been tucked away in the productions boxes. And we were able to look at it with the methods we developed in the meantime so that we could use organic chemistry to characterize the soil. And there were two different soils. One was from the wheat field from where she was found, and the other one was from the grass verge. So the prosecutors deduced that she had walked to her death in that field. And Angus Sinclair had said that he'd been away somewhere else and blamed it on his brother-in-law, the killing. And his DNA and his semen was on her coat, but he couldn't have been there because of the time that he said he'd been miles away. So they refuted his alibi with that combination of physical evidence. So yeah, and in that intervening period, the methods were all tested, published, validated, accredited, round robins tested. It had been used 3 times before that in court in England and Wales. And then since then, yeah, it's a lonely place to be in the box when you're questioned by very skillful defence cases. But that's as it should be. You should be able to defend your science, and you should be able to take difficult questions.
A question up by Adrian?
Sorry, I can't hear.
Again, what is the oldest cold case that you've ever solved?
It's probably the McDowell case for Rennie McRae and her son Andrew, that case where, again, those samples had been taken over 40 years ago. Well, the World's End murder was 1976, so both about quite similar time periods. So there is no time window on when you can go back, provided the samples have been taken, retained, and they've been kept in a reasonable, cool, dry environment, then we can look at them.
Can you hear me?
Yes.
In all the cases that you mentioned, I think there was already a suspect, and then you were able to look at the suspect's cars or shoes or whatever and form a link. Are there cases where there is no suspect and the forensic evidence can lead you to find a suspect?
It can help, what we can help the police work out who might be the suspect. So yes, that has happened where there's been multiple pairs of shoes. And for example, in a case where there were drugs being exchanged, the police were able to seize, I think there were about 8 pairs of shoes in this area, and they didn't know who'd been to the scene where the drugs were exchanged. So we took all the shoes. After the wearer DNA had been established within the inside of the shoes, then we independently looked at the soil and compared which ones had soil that could have come from the crime scene, and we narrowed it down to 2 of the pairs of shoes had soil on them, and that helped the police then investigate further with cell phone records, because all that's very expensive, digital forensics, so it's better if you can narrow it down, and then they focused their efforts and they found that these 2 people were connected with the crime. Yeah, so yeah, that's a brilliant question, thank you.
Yeah, can you hear me? Thank you for a really interesting talk. I was wondering if, like in the example when you sent the presenter to the woodland, if he'd gone to 2 different but very similar areas of similar soil type, would you be able to pick up like the 2 different areas? And also, would you know, like, he went to that one and then that one?
Well, it all depends on whether we've got discrete traces on footwear, and it all depends on how different they are, because the within location variation must be tighter than the between location variation. So I'm not saying we'll always be able to do it, and if you get 2 very, very similar woodlands, it might be more different to say one or the other. But thankfully, when suspects are being asked about where they got the soil from, they'll say, oh, I just got it from my back garden, or they'll probably not think that it might be linking them to a place, or they're advised by their lawyer to say no comment. But then, as I said, we've got alternative propositions that we can create a meaningful alternative proposition. But it won't always work. And if something's happened, for example, on a grassland playing field, and it's been manufactured, well maintained, and it's relatively homogeneous, and one field on the next, and they've been artificially created with the same bedrock and the same underlying sand material, it's extremely unlikely we'd be able to differentiate them. So yeah, that is a good question, and a point that we're not always able to do it. But in most cases, we can find something that's different. So we'd go to the next method, the next method, the next method, until we found maybe differences or strengthening that link between that question sample and that location.
I have a question. Can you hear me okay, Lorna?
Yes.
Can you hear me? The kind of cases you've described to us, they're very sad. I'm wondering if you ever get the chance to work on a case that isn't quite so sad, and I'd like to ask you about one that I'd like to know the answer to. Where did those 4 links come from that were released in the Highlands? There must be lots of cues that haven't been investigated.
Well, what you've just mentioned there is the application within wildlife forensics, and that is SASA, and Lucy Webster runs a unit there, and they would be able to take the material from these links,
Must have had
analyse
mud
the
on their
DNA,
feet.
and work out where the breeding stock and where they've come from. So they'll be working on it right now. And for example, they can identify the stock of peregrine falcons, for example, and to where they've been bred. So that's wildlife DNA, and that's a fantastic area.
Yes.
In Scotland, we've got SASA, which leads on that.
Yeah, I was more wondering about cues that must have been on their feet, their fur, and in the bedding that was found with them, which had some very strange things
Absolutely.
in it. And you seem the ideal person to...
Well, the trouble is there's not a lot of funding to investigate such crimes. And there's not, almost you would argue, there's not enough of a deterrent to stop people doing these sorts of environmental crimes. So we do work on environmental crimes. For example, the same principles of sewage sludge or contaminated land by an application, or we had an interesting one where we were asked by the National History Museum to look at some artefacts. They were being submitted as treasure trove to get some money because there were rare artefacts that were found in Perthshire. And the curator was asked by the police, you know, do you think this is suspicious? And they said, yes, we wouldn't normally find this type of jewellery for that type of provenance. So the archaeologist came in and they said, could you look at them to see if they actually came from there or if they could have come from somewhere else? So it's the same principle. What soil is on these objects? So we looked at the soil on the outside and coins, and right enough, that had the characteristics of the pit. We took reference samples of where they were allegedly found. And there was a hole there, so they had dug them, it had been disturbed. But what we did is we used ultrasound and we drilled down to within the little clasps of the jewellery and the layers underneath. And it was completely different. The material underneath was from down south. It was a different soil. It was a sedimentary soil. It was more calcium carbonate than any of our Scottish soils. And then the police investigated and they found that those same things had been sold on eBay about a year before from the south of Scotland, south of England, and these people were prosecuted for their fraud. So, yeah, that was kind of a nice conclusion. Yeah.
If we should take one last question at the back, please.
You describe some brilliant successes in your work, but I imagine it can't always be successful, and I wonder how these cases feature in the breadth of the work that you do.
Sorry, I didn't quite make out...
You're describing, obviously for presentational purposes, some brilliant successes in your detective work, but I imagine it can't all be brilliant success, and I wonder how these cases feature in the breadth of all of the work that you do.
I think the soil and the botany and any of the ecological information that we can bring to a case, it's never normally that on its own. It's normally a combination of evidence that is enough that the prosecution can take it to court. So we may only say this weakly supports the proposition that the soil came from there, but they could have a moderately strong link between the impression on the footwear and there, and that together, the combination of the evidence can be used by the prosecution to make their case. But I would just say that sometimes we also work for defence lawyers, and there's a case where we were able to show that an alleged rape was meant to have taken place in a particular location, and we were able to show that it could not have taken place at that location because the soil was completely different. So it's either side, it doesn't matter. And there are some times that it maybe doesn't add anything, or it's inconclusive, or the material's not enough. And that's what you report. You just say insufficient material to make any conclusion about whether there's a connection between X and Y. So it has to, we report the facts and then make an opinion based on the facts that we can glean from any analysis.
Thank you very much. I think you'll all agree we've had an absolutely fantastic and very, very informative and interesting lecture today. I don't think we can look at shoes, washing machine filters or tyres in the same way again, but I'd just like to give Professor Dawson a commemorative paperweight from the Society, and of course we'd like to thank her in the usual way.
Thank you very much. Thank you. And thank you for your wonderful questions. Thank you for coming along tonight, and thank you for your really interesting and thoughtful questions. And stay safe. And remember, you're more likely to be killed by somebody you know.